All right, so 7.1 is actually split into 2 days, guys. So day 1 is the intro to parabolas, which I know you feel like you already have an intro to parabolas. We're going to find out today you actually don't know everything there is to know about parabolas. So this visual is from your textbook, and I really like this one because I think it helps you understand what the conic sections are all going to be about. So if you have this shape, these like 2 little cones, and I take a piece of paper and I slice that piece of paper through part of the cone, but it has to be parallel to the base. You're going to create a circle, and depending on where that paper is, the larger the circle or smaller the circle. But if you take that piece of paper and you kind of tilt it slightly, you're going to create what's called an ellipse. What did you guys know an ellipse as when you were a little kid? An oval, yes. So it's kind of like a circle, but a little wonky. And then if you were to take that piece of paper and tilt it so much that the paper intersected with the base of your cone, you're going to create what we're going to look at today, which is a parabola. Now, you kind of already know this, but you've never had to work with it. Parabolas are not only vertical, they're also horizontal. So that's going to be the catch today. And then if you were to take that piece of paper and you were going to slice through both pieces of each cone vertically, or sorry, perpendicular to the base, you're going to create what's called a hyperbola. So this is the entire conic section from beginning to end. And once we get to hyperbola, that's when we'll have our first test on it, okay? So what's troublesome about the conic sections unit for me is dyslexia, because all of the formulas look really close. So you have to be careful, because when we change our eccentricity, we change our shape, and we'll learn about that later. But for today, we're just going to focus on what's called a parabola. And you don't know it, but I just made a really cute math pun when I said we're going to focus on the parabola, because there's something called a focus in a parabola. Right? That's a good one. Good one. Hee hee, ha ha. Now, my regular Algebra 2 kids, you have no idea what I'm talking about. You've never heard about a focus before? Or a directrix? My Honors Algebra 2 kids do have a little experience with that. Probably not enough to remember it, but we're going to see it again today. So, that's okay. We are going to look at, and this is the strange parabola, this is the horizontal one here, but this is some vocabulary that they're going to throw at you today. So a locus is just a set of all the points that fulfill that geometric property. So we could do a cute activity where we stand out in like the atrium, and I bring out like a string, and someone is our focus point, and then someone else carries the string somewhere else, and we create a big parabola trough. It'd be adorable, but it would be a waste of our time. We got to get through the lesson today. So instead, what I want you to notice about this parabola, there are some vocab words that you guys are very familiar with. Like, for instance, the vertex. You know what the vertex is. That would be the point of symmetry. Usually it's the top or the bottom of the parabola when you're in Algebra 2, but now we're going to have sideways parabolas. The axis of symmetry is the line that's going to split straight through the middle of your parabola. This is a new word for some of our friends. This is called the focus point. And it has a relationship with the distance to the vertex and the directrix as well. So this line right here is called the directrix. Here's the focus. Here's what I will tell you. The distance from the vertex to the focus is the same distance as the vertex to the directrix. That distance we're going to call the variable p today. That's the key to your question. Every time you start a parabola question, your job is to figure out what p is. Graphing today is going to be fun. We're going to have to do a lot of manipulation because this is the formula, these are the formula that we're going to be using today. So they kind of sort of look like something. Let's investigate this one a little further. You don't have to write this down, just kind of watch. This first one they listed, by the way, this is if a parabola is horizontal, you're going to use this version of the formula. That is, it's on your formula sheet. You guys see on the yellow one on the parabola side? There's a very clear differentiation between a vertical and a horizontal parabola. The formulas are all listed underneath it. So for me, I have to be really reliant on my formula card as I do these questions because I screw them up if I don't. But you guys typically haven't seen horizontal parabolas, but you've totally seen what's called a vertical parabola, which is this formula right here. So I'm going to investigate that formula with you for a moment. So x minus h quantity squared equals 4 times this thing called p, and then y minus k. Now, if I think about Algebra 2, I've never seen this before. Or maybe you have, but you never used it. Because in Algebra 2, all of your functions started with y equals, y equals, y equals. So can you guys help me rearrange this formula so that I solve for y? So this is a little challenging because first thing you have to do is move this term of 4p over to the other side. Now instead of dividing by 4p, what if I just multiply by 1 over 4p? Isn't that another way to, quote, get rid of a term? And then I don't have parentheses anymore. So what would be your final step in isolating this y? Adding the k over. So y equals this 1 over 4p thing, and then x minus h, quantity squared, and then it's plus a k. Okay, as I read that, that seemed really familiar. Doesn't that look a lot like your formula a times x minus h, quantity squared, plus k, which is vertex form of a parabola? So here's the new concept for today, guys. The a value that you guys know from Algebra 2, today it's going to be called this, because the value of p measures the distance from the vertex to the focus in Directrix. Okay, we'll get to that later. But think about what a meant to you in parabola land. If a was a number greater than 1, it like vertically stretched your parabola and made it skinny. And if it was a number between 0 and 1, it made it really fat, to use a bad term, but fat. So what you're going to see today, a whole bunch of fat parabolas. They're going to be horrible to graph, and I'm graphing them, so they're going to be extra bad. Okay? Here we go. This first question, I'm going to skip that slide. This first question is done for you, I think, on your paper, so just kind of watch on the board. But this is what you're going to see on your reference sheet. So a very clear difference between the vertical version of a parabola and the horizontal version of a parabola. So what I do want to caution you guys about, and you might want to write this on your notes somewhere, you need to make sure that whatever the quantity is that's being squared, make sure that's isolated before you start thinking about what formula you have. So like right here, this x minus h quantity squared, it's isolated in the formula. And then same thing over here, the y minus k quantity squared. If it's not isolated, you're going to have to do a little work first. There's a question coming up on your notes where we have that problem. All right, so like I said, you're just watching right now. So the thing that's being squared is the x minus h quantity squared. It is isolated, so I'm ready to investigate which formula am I looking at. So which variation of the parabola has an x minus something quantity squared? Is that the vertical or the horizontal one on your card? It's vertical, right? It's the one that's opening up or down. So this is a vertical parabola. I know it's already drawn for you, but vertical parabola. And the formula, if I'm comparing it to the card, the formula for a vertical parabola is x minus h quantity squared equals 12, and then y minus, no, not 12, 4p, and then y minus k as a quantity. So comparing the pieces of the formula, the very first thing you guys can find for me is something you probably could have found before I even started my lesson, the vertex. Well, you guys know the vertex is located at h comma k. So when I'm looking back at my formula, there's h, but what's k? There's that built-in negative, so it's really a negative 4. So it's 3 comma negative 4. So there's the vertex. Notice they've plotted it at 3, negative 4. The next thing that I would have you find is what is p, because p is kind of the key to this question. So in my formula, the number that's in front of the y minus k parenthesis is 4p. So kind of off to the side in my notes, I would set up, well, 12 is supposed to be 4 times p. So if you do a little solving, p is 3. P is the distance from your vertex to your focus and also your vertex to your directrix. So technically speaking, if I was like a visual learner, what I could do from here is I would notice that the focus is 3 units up here, but the directrix is 3 units below it. The trouble comes in, guys, is because you didn't actually, like when you do this for homework, you're not going to have a graph to look at. Your job is to graph it. So in order to know where the focus and directrix are located, we're going to have to do a little calculation. That's what I'm going to do right here. The focus, the formula from your card for focus of a vertical parabola is h comma k plus p. So remember how you have h and k and we just found p, so this shouldn't be that hard for us to find. So it was h comma and then k, which is negative 4. Oh, I wrote too big. and then plus p, which you just found. So that would be a way for you to calculate the focus point, which we now see is located at 3, negative 1. But that's where this star was. I'm going to mark it with a star on my graph, not a point. So that's the focus. The axis of symmetry is the same axis of symmetry that you guys always found in algebra. It's the line that goes straight through the vertex. So for a vertical parabola, that formula is not bad. It's x equals h. So for us, that would be x equals 3. I noticed they did not graph the the axis of symmetry of x equals 3. That would be this guy right here. Ooh, that was not straight. And then one more thing they'd make you find, which is the directrix. The formula from my card says for a vertical parabola, the directrix is, where are we at? Y equals k minus p. So for us, that would be y equals, where are we at? -4 minus 3. And that's how they came up with a directrix at y equals -7. Okay? So when I'm graphing these for homework, the first thing I do, because I know my limitations in math, and I screw up formulas unless I really concentrate on them. I find p. Once I figure out what kind I'm looking at, I find p, and then I go find each of these things in this exact order. And I just straight up use my formula. Then I take everything I find and I transfer it over to the graph. When we go to graph, there's actually one more step after this. We'll show you in the next example. But these are monotonous at times and very easy to mess up. So we have to kind of focus on what we're doing. That's another joke. Focus. Focus. Get it? Focus. All right, so this one's not done for you. Finally, some action. Here we go. First of all, the thing that's being squared, is it isolated? Is it all by himself on one side of the equation? It is. So what kind of a parabola are we looking at? If it's got the y quantity squared, uh-oh, this time it's horizontal. So the horizontal parabola formula is y minus k squared equals 4p times x minus h. I think for our notes, it would be brilliant to write that down right underneath it so you can kind of piece the puzzle together. First thing I'm going to do is figure out what p is. So 8 is the same thing as 4p. So if 8 is 4p, that means p is 2 when you solve it. All right, next thing that should be pretty easy for us to find based on our knowledge of parabolas, and even though it's sideways, it's still the same thing. Your vertex is located, remember, at h, k. So when I go back and look at my formula, the h is right there, and the k is right here. Watch out for built-in negatives. Where is your vertex located? At 3, -1. There's the vertex. If you would like to graph as you go, you're welcome to go graph 3, -1 right now. So next, I'm going to find the focus. The focus for a horizontal parabola is located at h plus p, k. I'm just stealing that straight off my formula sheet right now because I'm very new to this. I mean, I'm not, but you are. And then when I plug in all that information that I know, that would be, let's see, 3. But then you're supposed to add the p to it. So 3 plus 2, -1. So obviously we should simplify that. The focus point is at, where are we at? 5, -1. So your focus is at 1, 2, 3, 4, 5, -1. I don't plot those with points. I plot them with little stars or asterisks because they're not actually part of your parabola. Your parabola is going to hug the focus. So I can tell from what's developing here, guys, we're going to have a parabola that's going to kind of look like this. It's going to open up over here to the right. The other reason I know it's going to open to the right is because the p-value is positive, which means it's going to open, quote, traditionally. For a horizontal parabola, to the right is traditional. All right, got a couple more things we got to find, guys. The axis of symmetry is the line that splits it straight down the middle. So for a horizontal one, that would be at y equals, I always get this one screwed up now, y equals k, thank you. So that would be at y equals -1. And I know that's kind of something we skip a lot in algebra, but I'd like you to not skip it today. So we're going to need to rely on symmetry in a minute. All right, one more thing to calculate, and that would be the directrix. For a horizontal parabola, the directrix line is x equals, and then it's h minus p. So for us, that would be x equals 3 minus 2, which of course would be x equals 1. So I'm going to draw a line at x equals 1. And at this point, I should be noticing some really cool symmetry. Remember, the p-value of 2 is the distance from the vertex to the focus, or it's the distance from the vertex back to the directrix. So there should be some symmetry happening here with that p-value of 2. Okay, this is the part that kids don't like. You're going to have to give me one ordered pair. What's the problem with giving one ordered pair? That formula is a hot, hot, hot mess. This formula is not really great for giving ordered pairs. So the first thing you're going to have to do, and I apologize, I know you are running out of room. What I need you to do is solve for that single variable of, in this case, it's going to be solving for the single variable of x over on the right-hand side there. So what would be your first step in trying to isolate this x? How are you going to move this 8 over? You are technically dividing by 8, but how are we going to write that? Yeah, you're multiplying it by 1/8. So it's 1/8 times, I forgot what the rest of it was. Scroll. Y plus 1. Quantity squared. And again, I forgot what it was. And it was x minus 3. Now there's no parentheses anymore. So what's your final step in solving for this x? Adding 3 to both sides. Very good. So you get 1/8 y plus 1, quantity squared, plus 3 equals x. Well, that's great. So usually your next instinct is to be like, come here, calculator, and then you grab your calculator and you make him come up with a table. What's the problem? Yeah, this is like backwards. This is not a y equals table moment. So I need you guys, and there's really no wrong answer, but there are some less efficient answers. This time, I need you guys to come up with a y value that you would like to plug into this hot mess. So if you want to plug in a 0, you can. There's nothing wrong with plugging in a 0 as long as you don't mind working with fractions. So what do you want? You want to think a little harder, or you just want to go with the fractions? So think about what you're going to do here, guys. You're going to add 1 to it, you're going to square it, and then you're going to multiply it by 1/8. What about 3? Think, guys, think. Think that'll work. So y equals 3. What happens? 3 plus 1 is? Good, 4. 4 squared is 16. 16 times 1/8 is 2. 2 plus 3 is 5. You can plot the ordered pair 5, 3. Now, when you throw out 0 at me, it still is going to work. You're just going to have something a little less pretty to plot. So, oh gosh, 1, 2, 3, 4, 5, 1, 2, 3. Here's where your knowledge of symmetry is going to come into play. Remember, this is the axis of symmetry. So if this point is plotted on the parabola, that means traveling down the same amount will also be a part of the parabola. Did I not count right? That's 2. Oh, yeah. 3. Oh, it's even better. Okay, so now we get to make the world's fattest parabola. Ready? It's not even true. Oh, I missed. What a surprise. Oh, it's even worse. What do you know? Yeah, that's quality parabola right there. The symmetry part? Are we questioning that? Did I plot them wrong again? Gosh be golly, I was okay? Was it okay? Go! Alright. Anywho, oh, I was plotting up 3, but it was 4 units. Thank you. 1, 2, 3, 4. Am I good now? Because don't worry, I'm going to make it... What now? 1, 2... I'm plotting the order pair 5, 3. So 1, 2, 3, 4, 5, 1, 2, 3. There's a point. Now, the distance from him to the axis of symmetry has to match down here. So that's 1, 2, 3, 4 units. 1, 2, 3, 4. Okay. Oh. So you just wanted me to have another shot at graphing this. I get it, guys. Here we go. Oh, that was... Okay, okay. Back up. It didn't start good. Here we go. Oh, nailed it. You see that? That was beautiful at the end. Everything else was a hot mess. That bottom curve of that trough. Perfect. You're not impressed? Oh, okay. Well, then let's do another one. All right, are we looking at a horizontal parabola or a vertical parabola in this next example? It is vertical. So when the x is squared, it's a traditional vertical parabola. So we're going to be using, oh, it's counting by 2's. That's awful. Okay, so it's x minus h squared. The formula is 4 times p and then y minus k. So first thing I'm going to do is I'm going to figure out what p is, because that's going to be critical to my calculations. So if 4p is equal to 4, that means p is 1. So your knowledge of parabola should come into play here. Your vertex is always at hk. Just be careful who h and k are. H is, remember, with the x, k is with the y. So this guy has a vertex at -2, +1. So vertex at -2, 1. If you'd like to start plotting now, you can. Just be careful. They are counting by 2's. So -2, 1 would be right here. Kind of. All right, time to start calculating. We just found out that the p-value was 1. So now we can find the focus using our vertical focus formula, which is h comma k plus p. So for us, that would be -2 comma 1 plus 1. So that comes out to -2, 2. So I'm going to plot a little star at -2, 2. Oh, that's close. But that kind of makes sense, because what was supposed to be the distance between our focus and our vertex? 1 unit, and if this graph is counting by 2's, that's like a half of a block, so I think we're on the right track. All right, axis of symmetry. For a vertical parabola like this, the axis of symmetry is x equals h. So that means we have x equals -2. Doesn't surprise me. It's supposed to go straight through the vertex. And then the directrix. Anyone think they know what it is without calculating it? If it's equidistant, it's going to be at 0. Oh boy. So the formula for directrix is, for this guy, it's y equals k minus p. So for us, that would be 1 minus 1, which, yes, it is 0. So, back to my graph. Oh, yeah, that's ugly. To kind of connect it to an old idea, I said earlier on a slide that the a value from old school parabola is the same thing as 1 over 4p. So if I kind of want to connect those old ideas to my new ideas, remember this is 4p. So we're going to be graphing a parabola that is essentially has an a value of 1 over 4. Can you talk to me about what this parabola is going to look like? When you were a little kid, would you have described this as normal, skinny, or fat? if it's got an a value of 1/4. Fat, yeah. So here we go. I need a point. But my problem is I don't have a point. So I'm going to need to take that formula and I'm going to have to rearrange it for y. So where did my page go? The original problem is x plus 2 squared equals 4 times y minus 1. What would be your first step in you trying to isolate that y right there? Yep, hitting both sides by a 1/4. And then your final step is going to be just adding that 1 over. So finally, and I'm going to rearrange it a little bit if you don't mind. I'm going to say y equals 1/4 x plus 2 squared, and then we added the 1 over plus 1. This is our parabola that we're supposed to find a point for. Now, good news. It is in our normal calculator of y equals form because it's traditional vertical parabola. So if you really were like, I'm going to use a table, you go right ahead, kiddo. I don't think we need to, though. Can anybody think of an ordered pair? You get to choose x this time. What would you just really love to plug in right there for x? 0? I'll try that. Sounds good. All right. 0 plus 2 is 2. 2 squared is 4. 1/4 times 4 is 1. 1 plus 1 is... Let's plot the ordered pair 0, 2. Now remember, it's counting by 2's, so this is 0, 2. If I use my law of symmetry here on parabola, that means it's over here is another symmetrical point. And then we graph the world's most beautiful... It started so good. And then I like hold it at the last minute. It started good though. You gotta give me a little grace. This is tough, right? It's tough. Man. Alright, let's try another. Because why not? Are we on the back? For the sake of time, let's actually skip to number 4. So, I gave you a little word of warning when we were starting this formula up. I said, don't start diving into the formula until your formula is in the right form. So as I look at number 4 here, I don't think we're ready. See how that negative 1/12 isn't supposed to be there? So what could you do to take the negative 1/12 and, quote, move it to the other side? Yeah, multiply both sides by negative 12, the reciprocal. So multiplying this one, they just cancel, but then you're going to throw a negative 12 in front of that. So new formula. Same function, though. X minus 3 quantity squared equals now a negative 12 times y minus 6. So now that it's in the right form, I can explore this a little more. Is this going to be a vertical or a horizontal parabola? This is a vertical one. So that's good. It's the one we're used to. The vertical formula, remember, is x minus h quantity squared equals 4p times y minus k. So kind of pulling all those thoughts together, first thing I'd like to calculate is the p value. So negative 12 is equal to 4p. So that means p is negative 3. What do you suppose that's going to mean for the shape of my parabola? It's going to be upside down. It's going to be reflected. So a negative p value is equivalent to saying a negative a value because it's 1 over 4p. All right. So we're going to use that. Let's do the easy part first, though. Where's your vertex? It's that h and k again, right? So I heard 3, 6. So then let's go find our focus. For a vertical parabola, the focus is at h, k plus p. So for us, that would be 3, and then 6 plus negative 3. So what's that going to do for your focus location? It's actually going to move it down 3. That's okay. So this is at 3, 3. So I'm gonna plot the vertex with a normal point, but I'm gonna plot the focus with like a little star. And they're counting by 2's again. I hate this. Okay. Vertex at 3, 6 would be right here and up 6. And then the focus is at 3, 3, so that would be over 3, up 3. And remember, you guys warned me this was going to be an upside down parabola, a reflected one, so yep, I think you're on the right track. Calculate a few more things for me. I need axis of symmetry, which is going to be x equals h, so x equals 3. Totally. And then the directrix, which for a a vertical parabola, the directrix is y equals, and then it's k minus p. So be careful on this one, guys, because it would be 6 minus a negative 3. So you're going to have a directrix at the line y equals 9. But that kind of makes sense, because 9 would be right here. And remember, the distance of p, which is negative 3 units, but 3 units, the negative just means it's upside down, should be the distance from your vertex to your directrix, and also your vertex to your focus. So everything's kind of lining up well. This is good. Now for the fun part. I need one ordered pair. But I need you to rearrange this formula, because I can't use it the way it looks. Now, here's an interesting thought. What if we went back to the very, very, very original version of this question? Remember how the negative 1/12 was already moved over? Let's start from there, because then you only have one step to solve for y. What would you have to do then? Just add the 6 over, and then we're done. So negative 1/12, x minus 3 squared, and then you guys told me just move the 6 over by adding it. Boom, done. All right, however, that doesn't help me come up with a number. So on the last class when we did this question, like, they were hemming and hawing over points for like quite a while. And then finally we just gave up when we're like, you know what, I don't care. I'll just take a fraction at this point. Because it was frankly just too arduous for us to come up with a good ordered pair. Does anyone think that? Oh, you got one, Lars. 9. All right, let's try it. I'm trusting you. It says go for 9. Alrighty. 9 minus 3 is 6. 6 squared is 36. Negative 1/12 times 36 is negative 3. Negative 3 plus 6 is 3. Do we get it? Okay, cool. That was a lot of mental math. Thanks, Lars. That was a good one. I already forgot what it was. It was 9/3. Ah. Does anybody else really hate when they count by 2s? Like, I understand why, because they're trying to save space, but like, gosh, I'd just rather use another worksheet at this point. This is horrible. All right, oh boy, symmetry. Oh lordy. This is at 3 and this is at 9, so that was 6 units, right? So we're supposed to back up this way 6 units. So I need to get to negative 3. Ah, right here. Okay, that was horrible. Well, the good news is everything you guys predicted for me was right on track. You told me I had an upside down or reflected parabola. We didn't really discuss it, but if the 4p was negative 1/12, that's the same thing as saying you have a parabola with an a value of negative 1/12. Like, that's an upside down, super chunky parabola, isn't it? So everything you thought was going to happen, it happened. So these are fun. What happens if we don't give you all that information? We give you different information. So here I gave you a graph and I gave you some pertinent information. I want you to come up with the equation. So it's kind of halfway done for you. They graphed this sideways parabola. Now, are you noticing that this is opening to the left? What do you think that means? The p value is going to be negative. Very good. So dyslexic teacher knows that in her head, but is very worried about messing it up anyways. So I'm still going to use my formulas. This is how I'm going to approach this question every time. Because it's a sideways or a horizontal parabola, this is the formula we're going to be using. And the idea is all you need to figure out for me is h and k, and you're going to have to figure out p. Once you have those 3 pieces, you're done. Well, good news. Totally have h and k, because they said flat out your vertex is at 1, negative 3. So there's h and k. However, the focus point is going to help us calculate p. So look at the focus point. For a sideways parabola like this, the focus point formula is, let's see, it's h plus p comma k. So this guy, h plus p, is supposed to equal 4. Sorry, negative 4. Hey, but don't you know h? What's h? It's 1. All right, guys, solve for p. Subtract 1. Turns out p is negative 5. And remember, you guys predicted that for me. You said the thing was going to be negative because it was opening to the other direction. So p is negative. It works out in the calculations. That's awesome. All right, now we just throw everything in the formula. So what we got here, y minus negative 3 will be y plus 3 squared equals 4 times negative 5. I'm just going to throw that as a negative 20. And then x minus 1. Voila! Standard form of a parabola. All right, let's try another. The next few, they want me to graph them. For the sake of time, we're not going to, because clearly that's where I struggle. But I think the part of the problem where some of us are going to struggle is just isolating the function for the x or the y. I think that's troublesome for some kids, so maybe we'll do that step and then we'll move on. So this question, they don't really tell you much and they don't even give you a graph, so you can't even go off of that. So you really have to investigate the formulas very carefully. It says we have a focus point at negative 1, 5. I'm going to go ahead and kind of halfway graph this. I'm going to mark a focus point at negative 1, 5. And they're counting by 2's again, of course. So negative 1, 5 would be like right here. But the vertex is at 2, 5. So I don't really know exactly what this looks like, but if the parabola is supposed to hug the focus point, looks to me like we have a sideways, a horizontal parabola who's been flipped over, reflected. Okay, so keep that in mind. All I want from you guys is, can you write the equation for me? So the equation that we're going to be using is the y minus k squared equals 4p times x minus h. Well, good news. You guys totally already know h and k. But you got to figure out p. So I know some of you are looking at this graph going, I already know what p is because it's just the distance between the focus and the vertex. And I know it's negative because of the way it's opening. If you can do that, you're extra awesome. I am not. So what I'm going to have to do is I'm going to look at the focus formula for a sideways parabola. The focus formula for a sideways parabola says it is h plus p comma k. So this h plus p is supposed to be negative 1. So h plus p equals negative 1. However, back it up, you know h is an h2. So subtracting 2 to the other side, you get p equals negative 3. So everything you were predicting for me, and now that I look at it, I go, oh yeah, duh, that is totally negative 3 unit for p. That makes sense. All right, put everything back into the formula. You have y minus 5 quantity squared. 4 times this would be negative 12. And then x minus 2. Whew, lovely. Just for funsies. Let's see if you guys can solve for that real quick. I'm going to freeze the screen and I'll pause the video. All right, see how you did. Did you get that? Oh, cool. So then I would like kind of live and learn from Lars's example. What was like a really good number to figure out in square and then multiply later? So like he made it a 6. So can you figure out what to plug in here to make this a 6? It'd be an 11. I'm not real excited about that number now that I think about it. But what if I made this a negative 6? What if I plugged in like a negative 1? Because that would be 36. Okay. So if you're trying to find nice numbers to plug in, like if it's more energy to find a nice number than to just plug in a 0, then just plug in a 0. Like you're okay with fractions and decimals, guys. I will suggest if you end up with plugging in something that doesn't come out to a nice value, rather than like bringing it back to a fraction, like call it 5.25. Don't call it 21 fourths or whatever that is. Okay, because you're going to be plotting it, so decimals would make more sense. This one's fun. Gives you lots of clues. It says your directrix is at y equals 6. So you go, cool. Graph that. And this bothers me tremendously. Is this the one or is that? There's one on here where like one axis counts by 1s and the other axis counts by 2s. Did I already? Oh. It was the one we were just looking at, wasn't it? No. I feel like there was one. Where was it? Oh, you know which... Was it this one? I don't know. Whatever. Anywho, they do that sometimes. I just want to warn you. Once in a while on your notes, they'll have like a vertical axis that counts by 2s, and the horizontal axis counts by 1s, and it really messes with me, so watch out. Alright, so we have a directrix at y equals 6, and you have a vertex at 5, 3. Cool. And it opens down, which, yeah, it would have to, because of where the directrix is located. So that was a nice little clue they gave me, but I don't think I needed it. If you are going to write the formula, you have h and k, you would have to find a. So, if you could just tell me the distance from here to here, I think you have a, except you're going to have to remember one thing about it. Okay, this is what, 3, and this is 6, so that's a distance of 3 units. But because it's going to open downwards, what do you know? It's negative. So what I just did was I used a graphic approach to finding a. P, not a, P. A graphic approach to finding P, sorry. Rather than using the formula. And see what I did? I screwed it up, and that's why I don't do it that way. Alright, so throwing it into the formula, you guys would have, let's see, x minus 5 squared equals 4 times this would be negative 12. And then y minus 3. Ta-da! Okay. You guys have a short book assignment. I gave you a packet of bookwork to be working in. It's just part 1 of the book assignment. We're going to continue parabolas on Monday.